let's move 10.3, which is sound intensity. At the end of this topic, you should be able to define and use sound intensity, discuss the dependence of intensity on amplitude and distance from a point source by using graphical illustration. So for 10.3a, you have to define and use sound intensity, where the equation is I is equal to E, which is energy, over TA. So E over T, also known as power, so you can have I is equal to power or area. So this is the derivation for sound intensity equation. As the sound wave flows out from the source in all directions, hence it is a three-dimensional wave and is said to be spherical wave. So that's why our area is equal to 4 pi r square, because the sound coverage area is in sphere. Alright, so we have 10.3b, we have the discuss the dependence of intensity on amplitude and distance from the point source by using graphical illustration. From the relationship between intensity and distance from the observer, so I is equal to power over area when the source move towards observer. Okay, when the source move towards observer, so this is observer, this is source. Okay, source. When the source move towards observer, so the source move to observer, so R will be decreasing. So we know that I is equal to power over 4 pi r square, or I is inversely proportional to r square. So when r decreasing, so then the intensity will be increasing, so the loudness is increasing. When the source is moved away from observer, so when the source is moved away, okay, so then the distance will be increasing. So when the distance increasing, I will be decreasing, because I inversely proportional to r square. When r increasing, so the intensity decreasing, so the loudness decreasing. So we have 2 points of distance r1 and r2, because we have I1 inversely proportional to r1 square and I2 inversely proportional to r2 square. So we have I1 over I2 equal to r2 square over r1 square. Alright, or you can have this one. The factors that influence sound intensity, first we have amplitude, where the sound intensity indirectly proportional amplitude square, and the distance from the source, the sound intensity inversely proportional to distance square. So this is the graph that relates the variation of sound intensity and distance. Okay, we have graph A, I and r square, and we have I versus I1 over r square. This graph relates the variation of sound intensity and amplitude. We have sound intensity versus amplitude for graph C, and sound intensity versus A squared for graph D. A squared. So this is example 10.5. A loudspeaker radiates sound wave uniformly in all directions at distance of 3 meters. 3 meters, and the sound intensity is 0.85 watt per meter square. Calculate the power of the loudspeaker. So from the definition, I is equal to power over area, so we have to find the power. So power is equal to I 4 pi r square. So you substitute r, which is 3, so you have 96.13 watt. And then you have to find the sound intensity at distance of 6 meters. So to find the sound intensity at distance of 6 meters because the power is constant. Remember that the power is constant. So then you will have you substitute R, which is 6 meters, into this equation, and then we'll have the sound intensity is 0.212 watt per meter square. Okay, good luck. Bye.